Hello everyone, we are Team 11 and we will be presenting our information retrieval project. Our team consists of 6 members, Gabriella and Stephanie as front-end engineers, Shearman and Lam as machine learning engineers, and Khang and Duke as back-end engineers.
Let's move on to the selection of topic. Our team decided to individually conduct a simple exploratory data analysis on multiple topics, and after the discussion, we choose hate speech and toxic comment on Twitter. The first reason we select this topic is that hate speech and toxic comment can be commonly seen on Twitter, which means that we will be able to have sufficient raw data to be used to build our text corpus. For this topic, we will be able to perform multitask classification of the text, classifying their subjectivity as well as the toxicity level, due to the fact that we are required to manually annotate 10% of the text corpus for use at the validation set for our classifier. It will be laborious to have to manually annotate a large amount of text to be used to train our classification models. If we choose this topic, we can use a dataset on Kaggle for toxic comment classification containing a huge amount of pre-annotated Wikipedia comments. This means that we will be able to make use of this pre-annotated Kaggle dataset, and we can afford to manually annotate less amount of text from the text corpus and still have enough training data to train our classification models. The use of social media platforms such as Twitter has enabled us to be able to freely express our thoughts and ideas online. However, the rise of free speech as well as the ease of posting comments on Twitter give rise to the negative online behaviors like toxic comments. Therefore, there is a need for tools to detect the presence of negative online behaviors as well as the toxic comments in order to shut down negative online behaviors and toxic comments from the social media platforms.
Now we will move on to the section on classification. Our team's classification tasks are subjectivity and toxicity classification, where we are required to classify a tweet as whether it's subjective or objective, and whether the tweet is non-toxic, toxic, or severely toxic. In order to tackle the multitask classification problem that our team has defined, we decided to make use of pre-trained state-of-the-art transformer-based machine learning models, such as BERT and Robota for our classification. The reason for using transformer-based machine learning models is because transformers are designed to handle sequential data such as natural language. The use of transfer learning in our classification approach also helps to speed up training and improve the performance of our classification model. In addition to manually label data from the crowd text corpus, our team also made use of the Toxic Comment Classification Challenge dataset from Kaggle for training our models. The additional data provided a classification model with sufficient training data for them to learn the classification task without the need for manually labeling a huge portion of the crowd text corpus. To further enhance the classification accuracy, our team made use of ensemble learning. Ensemble method uses multiple learning algorithms to obtain better predictive performance than could be obtained from any of the constituent learning algorithms alone. For ensemble learning, our team selected the BERT and Robota models for ensembling. With the classification approach that our team has developed, we are able to obtain good classification results for multitask classification, obtaining respectable S-measured scores for each of the class for both subjectivity and toxicity classification.
Now let's move on to the implementation section. This is what the web application looks like. At the top, you have a space to input your queries and a search button. The number of tweets is shown at the top of the app. We can first demonstrate a few such queries. For example, if the query is fuck, the list of tweets being queried is shown here. Each page shows 100 tweets. One can click the next arrow button at the bottom of the screen to go to the next 100 tweets. The tweets results are ranked based on the BM25. Now, let's try the query fucking. As we have performed stemming, the query fucking should map to the root word fuck, as shown in the first result here.
Since some provide suggestions based on the created index and works in the lowercase form when the index is built, all suggestions are in lowercase form as well. For example, we perform a demo query fig. As the fig query returns no matching result, our search engine provides alternative search query such as fuck. User can click on the suggestion to execute and see the result of the suggested fuck query.
Under the search box, you have 3 types of filter. On the left, you have the country filter where you can filter a query based on its origin. This is the geospatial innovation being implemented. It shows where in the map the country a tweet is from.
The filter in the middle filters a query based on the subjectivity classification, while the filter on the right filters a query based on the toxicity classification. For example, if you wanted to display subjective and severely toxic tweets, you can simply choose the filter from the drop-down. Once you click the search button, you will see in the list of tweets the tags that show that the tweets are indeed subjective and severely toxic. The enhanced search innovations are elaborated next. There is a chart on the second slide containing the toxicity and subjectivity classification distribution of the query database. It shows the ratio distribution of a query in the entire database. You can hover over the chart to see the number of tweets in that particular category. For example, when there's no query, this is what the chart looks like, while when you input a certain query, say loser, the chart updates itself. The third slide shows 2 donut charts of the toxicity and subjectivity classification distribution of a tweet in some selected country. You would have to select a country to display the tweet classification distribution ratio. For example, when we select the United States, we can see the tweet distributions in the United States. We can also query the word dumb and see the tweet distribution to queries containing the word dumb in the United States.